When neurotransmitter molecules are released from a neuron, they pass the signal to the next neuron by interacting with receptors on that neuron. Welcome to 2-Minute Neuroscience, where I simplistically explain neuroscience topics in 2 minutes or less. In this installment, I will discuss receptors and ligands. When neurotransmitter molecules are released from a neuron, they pass the signal to the next neuron by interacting with receptors on that neuron. These receptors are made up of proteins embedded in the membrane of the postsynaptic cell. There are two broad families of neurotransmitter receptors. One type are called ionotropic receptors. Ionotropic receptors have a site where a neurotransmitter can bind called the binding site. When neurotransmitter binds here, it causes a channel to open in the receptor and ions are permitted to flow into the neuron. This can change the membrane potential of the neuron and send a signal known as the action potential down that neuron. The neurotransmitter that binds is called the ligand, which is just a term for any substance that can bind to a target protein. Thus, ionotropic receptors are also called ligand-gated ion channels. The other type of receptors are metabotropic receptors, also known as G-protein coupled receptors. Neurotransmitters also bind to these receptors, but instead of immediately opening an ion channel, the next step after binding is the activation of an intermediate protein called a G-protein. The G-protein can then influence the opening of ion channels, but it can also affect enzymes and activate intracellular signaling molecules known as second messengers, which can initiate signaling cascades within the cell. G-protein coupled receptors thus tend to have a slower action, but can have more widespread effects due to their ability to influence various molecules throughout the cell.
What are neural networks? Let's answer in 60 seconds. A neural network is a group of what is called artificial neurons. ANs were inspired by the neurons in our brains, and this is what they look like. Putting a group of neurons together creates a layer of neurons. And there are three types of layers: input, hidden, and output layers. Each network has one input and one output layer, but it can have more than one hidden layer. The only goal of the input layer is to pass the input values to the hidden layers, whereas the output layer also has some calculations done inside of them. The hidden layer is where the actual magic happens though. Let's take a closer look. Let's say our neuron has three inputs, X, Y, and Z, and each of these inputs come with their own weights, and the neuron has a bias. We multiply each input with its corresponding weight and add the bias to it. This value is then passed through an activation function to calculate the output of the neuron. Doing it for all the neurons in a layer at a time, and doing it for all the layers, we can calculate the output of a neural network. During training, this calculated result is compared to the true value, and the weights and biases of the network are updated to get closer to the correct result. What are